Welcome to this video on trend lines. You can download the exercise workbook to follow along in your own copy of Tableau. Trends can provide important insight into an analysis. For example, here answering the question, by how much does our power output go up with wind speed? We can see the relationship here. When wind speed increases, the power output increases. But how exactly? If we have a view with numerical data on both axes, it's easy to add trend lines to the view. Click on the Analytics pane and drag Trend Line to the type of model you desire. Removing trend lines is just as easy. Right-click and uncheck Show Trend Lines. By default, trend lines are per pane and per color. Back on the Data tab, if we were to bring another dimension into the view, such as location, we'll get a trend line per pane or per scatter plot. Similarly, if we were to move location to color, our trend line breaks out into 3. If we want to see our location on color, but only have one overall trend, we can modify the trend line. Modifying the trend line takes a simple right-click, select Trend Lines, Edit Trend Lines. Unchecking Allow a trend line per color will bring us back to a single overall trend line. We can also uncheck Show Confidence Bands to simplify the view. There are several other things we can control in this dialog box. First, the model type. These are the first options as when we first bring out trend line from the Analytics pane. These options tell Tableau to build a linear regression model based on the type of transformation on one or both variables. Linear refers to the coefficients, not the relationship of the variables. Models may be linear, logarithmic, polynomial, or exponential. For more information on the model types and transformations, the online help article on trend line models provides some excellent information. The confidence bands show the 95% confidence interval for the model, and we could also force the y-intercept through 0. It's important to assess if a trend line provides valuable information. Hovering over the trend line brings up a tooltip with the trend line equation and the p-value. In statistics, p-value is the number assigned to the concept of significance. If the p-value is less than a cutoff, usually 0.05, the results are interpreted as significant. A large p-value, on a scale of 0 to 1, can indicate that the apparent trend in the data is due to chance, not the factors in the model. In this example, the trend line has a very small p-value, which is good. However, to correctly assess if a model is a good fit, we need to know more than the p-value. Right-clicking and selecting Describe Trend Model brings up the full model summary and ANOVA table. One of the values we see here is r², which effectively tells us how our model fits the data. R² values range from 0 to 1, and higher values are considered better. We see in our example that the R² is very high, at 0.956. This means our model fits the data very well. An R² of 1 indicates a perfect fit, but beware that if your R² is incredibly high, for example 0.999, your model may be misleading. A common indicator of an artificially high R² value is low degrees of freedom or just having too many observations. Note, for an in-depth discussion of the information presented in the model description, see the online help article, Assessing Trendline Significance. And as with any statistical test or model, it's important to make sure your data meet the assumptions and the analysis is applicable. To decide if a trend line accurately represents the data, it's not enough to have a small p-value or a large r². Not all of our points will fall on the predicted trend line. The distance from a given point to its predicted value is the error, or residual. In a correct model, those residuals should follow a random normal distribution around the 0 line when plotted against the explanatory variable. This residual plot isn't normally distributed. It indicates there are trends in how the data fail to line up with the predicted values, which means the model isn't the best. To get the residual values for a view with a trend line, go to Worksheet, Export, Data. This will prompt us to save the file, The only format option is Microsoft Access. We'll name it Trendline Data. And hit Save. We'll choose Connect After Export. This data source has the original data from our scatter plot, as well as the predicted values from the trend line and the residuals, the error from the predicted values to the actual data. The residual plot is constructed as the exploratory variable on the horizontal axis, wind speed goes to columns, and the residuals on the vertical axis, on rows. And we'll bring windmill to level of detail. Remember, a good model has a normally distributed scatter around 0. This means the mark should be centered on 0, denser there, less dense farther from 0, and the pattern should remain the same across the horizontal axis. Clearly, our model is not very good at predicting our power based on wind speed. Although the p-value and r² for the trend line are good, the residual plot is awful. This trend line is not useful for the analysis. That's an overview of trend lines in Tableau and how to interpret the relevant statistics around them. Thank you for watching, and we invite you to continue with the on-demand training videos to learn more.